Welcome student. The gravitation stills. I am continuing the gravitation chapter. Already three, four videos I have already made. Now today I am going to explain the equations of motions for freely falling body. Last video already I explained that if you drop different masses, different size, different shapes of the bodies together from a height, then they all will fall together on the ground. Okay, so today I am giving explaining the equations freely falling bodies, equations of motions. Now you know by the first chapter, that in motion chapters, already given the equations of motions. That means what we know, that equations of motions, equation number 1, V is equal to U plus AT. Okay, number 2, S equals to UT plus half AT square, and equations 3 equals to V square equals to U square plus 2 AS. Okay, these three we have already explained in the first chapter, the equations of motions for the moving object which is moving in the horizontal plane. Now how I will convert these three equations of motions into the equations of motions for freely falling body. Here, this you know, again, though you know that again I am telling, V is the final velocity, U is the initial velocity, A is the accelerations due to the force, and T is the time by which the moving object getting the accelerations A. Okay, and S is the distance covered by the moving object, and these are the all the data I am explaining. Now how it will change. So when the body falling from a height, so in a vertical plane, then the accelerations due to gravity is equal to G. Okay. When it will falling, then the G, the accelerations due to the force of gravity, that means the attractional force of the earth on the object. Suppose here the object, and here is the earth, then the object, then the object attractional force, the force of gravity A, due to this force, the accelerations produced in this object is G. Okay, this is called accelerations due to gravity. Now here, and suppose this height is h, this height from height h, the object is falling on the earth, then what? The equations will change. The equation number 1 will change, that V equals to U plus GT. So accelerations A will be changed into G, accelerations G. Okay. Now number 2, S is the horizontal distance, but here we have to write, we will write the H, that means vertical height. Then H equals to UT plus half GT square. Okay, now 3, equation number 3, V square equals to U square plus 2GH. So A will change into G, S will change into H. Okay, in this way, if you get the numerical problems, that means our object is falling from a height from H, and that initial velocity, final velocity, time, everything given, that time you have to use these formulas. Okay, not this formula. But when the object will be moving in a horizontal plane, that in a straight line, that time you will use this types of formula. Now, if I throw an object from here to there, okay, so in this way the G is negative, because since the attractional force by the earth on the object is to downwards, then the G, if I throw the object upwards, then what will happen? That means the accelerations due to gravity is downwards, but the object is going upwards. In this case, the accelerations will be negative. Okay, the G will be negative, minus G, opposite directions. Okay, that time this equations will change. V equals to u minus gt and h equals to ut minus half g t square and v square equals to u square minus 2gh. So when you will see the object is throwing, when you get the numerical problems, you have to see whether you are the objects you are dropping from a height, or if the object is dropping from a height, then these equations you have to utilize. And if in the problem sums that if you throw the object from earth's surface to upwards, then this formula you have to use. Okay, because that time if the object will go upwards, then the g will be negative. Accelerations due to the attraction force will be negative. So these are the forces of equations of motions of a freely falling body. These are very important to solve the numerical problems based on these equations. Okay, now I am telling variations of acceleration due to gravity. I already told that again for your clear conceptions that the relations what I have given, F equals to G M capital M and small m by r square. This is the force of gravity. Okay, force of gravity is the force by which the earth is attracting the objects towards its center. This is called the force. Now we know by this one, the force equals to weight of the object. The weight of the object is nothing but the force. Then weight is, I have to write mg. So the mg, g is the accelerations due to gravity. Now in place of F, if I put m into g, then what will come? G capital M small m by r square, or g equals to g m by r square. Now see, accelerations, I already explained you that accelerations due to gravity does not depend upon the mass or size or shape of the object, because this g is the acceleration universal constant g, and gravitational constant m is the mass of the earth, and r is the radius of the earth. All are constant. Now if an object, suppose this is the earth, and if an object is here, that means h. So what will be the accelerations due to gh at the height h from the earth's surface? Now see the r is this one, capital R, this is r. Okay, now this one, this height equals to r plus h. Okay, this height is equals to r plus h. Now if I put gh equals to, this is ge, and gm by r plus h whole square. Now you see, if the denominator will increase, then definitely this one g will decrease. Now see the r plus h definitely greater than the r. The r plus h, since the denominator is increasing, then therefore definitely gh will be decreasing. So that's why the gravitational, the acceleration due to gravity at the height h will be lesser than, that means gh will be lesser than ge. Then the attractions on the earth's surface, the accelerations due to gravity on the earth's surface, it will be greater than the accelerations at a height at a height h of the object is lesser. In this way, now with the variations of the now since our earth is not a fully circular ball, it is just in the pole side just taper, and this one in the middle one it is blood, this is just bulge. So that's why near about 10.5 kilometer more. The radius at the equator, this is called equator, imagine this is called pole, this is called equator, and here the radius at the equator is much more than the radius at the pole. Okay, that's why since radius at the equator is more, near about 10.5 kilometer larger than the radius of the earth at the pole. So what will happen? Then we can write G pole will be greater than the G equator. Why? Because since the radius at the equator is much more than the radius at the pole, since the down one, if down one will be greater, then the up one will be acceleration due to gravity will be less. That's why the accelerations due to gravity in the pole is much greater than the accelerations due to gravity in the equator. Why? In the equator, the radius is larger, and that's why if it will increase, suppose plus x, then it will more. So that's why equators, the accelerations due to gravity at the equator will be less. So what is the questions is the accelerations due to gravity in the pole is greater or lesser than equator? Then your answer will be that accelerations due to gravity at the pole is much more than the accelerations due to gravity on the equator. Okay, so this is the variations of the accelerations due to gravity. Now suppose if this is R, now suppose if an object is going inside as a depth of x, then what will happen? Since this is the R, radius R, but where the object will come up to here, then what will happen? Then this portions, the ring of this earth, this much earth ring does not affect the object on this surface. So this objects only this much surface will be affected, and this much mass of the earth will attract the object. So that's why in this case that the accelerations, suppose at the point x equals to, in this formula, that gx equals to 1 by gx by g. In this formula it minus x by r. In this formula this gx, or you can write g. Okay, gx will be this formula when in senior classes, in class 11, so you get the derivations. But for your conceptions, in these relations, the accelerations due to gravity inside the earth will vary in this way. Now if x become r, then what? This 1 minus 1 equals to into z, it means 0. That means 1, if the object come to the center, that time the gx will be 0. That means that time the accelerations due to gravity at the center of the earth is 0. That is the relations of the variations of the accelerations due to gravity. Okay, and this way we can explain the variations of gravity due to attractions. Thank you.